Hello friends, and welcome to Webronaq. Have you ever stacked plates after washing the dishes? You put a clean plate on top, and when someone needs one, they take from the top as well. That simple idea is exactly how a stack data structure works in computer science. In this video, we are going to break down the stack from the ground up. We will cover the core principle behind it, the 5 operations that define it, how to use it in C++ with the standard library, and where it shows up in real software. By the end, you will have a solid mental model and working code to back it up. Let us start with the one rule that makes a stack tick. The rule that governs every stack is called last in, first out, or LIFO. Think back to those plates. The last plate you placed on the stack is the first one you pick up. Elements enter and leave from only one end, which we call the top. In our diagram here, we pushed 4 numbers onto the stack in order. 10 first, then 20, then 30, and finally 40. So 40 is sitting at the top right now. If we pop an element off, 40 leaves first, then 30, then 20, then 10. The order of removal is the exact reverse of the order of insertion. This single rule, LIFO, is what makes stacks powerful and predictable. Next, let us look at the 5 operations that let you work with a stack. Every stack, no matter how it is implemented, exposes 5 fundamental operations. Push adds a new value to the top of the stack. Pop removes the element currently at the top. Top, sometimes called peek, lets you read the top element without removing it. Empty tells you whether the stack has no elements at all, returning true if it is empty. And size returns the total count of elements currently stored. These 5 operations are your entire interface with a stack. You never access elements from the middle or the bottom. Everything flows through the top. That constraint is not a limitation, it is actually what makes stacks so useful in specific problems. Up next, let us see how C++ gives us all of this out of the box. C++ ships with a ready-to-use stack through its standard template library. You just include the stack header at the top of your file. The class is called stdStack, and it is a template, meaning you tell it what type to hold inside the angle brackets. Writing stack of int declares a stack that stores integers. We name ours s. From there, calling s.push with a value drops that value onto the top. In these 3 lines, we push 10, then 20, then 30 onto s. No manual memory management, no custom node structs. The STL handles everything under the hood. By default, stdStack is backed by a deckway, but that detail is hidden from you. All 5 operations we just covered are available as methods on this object. Let us now walk through a full example and trace exactly what happens. Let us trace this program line by line. We declare a stack of int named s. Then we push 10, 20, and 30 in that order. At this point, the stack holds 3 elements and 30 sits at the top. Line 10 calls s.top, which reads the top without removing it. So cout prints 30. Then line 11 calls s.pop. That removes 30 from the top. Now 20 is the new top. Line 12 calls s.top again and cout prints 20. Line 13 calls s.size. We started with 3 elements and removed 1, so size returns 2 and cout prints 2. 3 lines of output, 30, then 20, then 2. Every step follows directly from the LIFO rule. Push adds to the top, pop removes from the top, and top reads the top. Clean and predictable every time. Now let us see where stacks show up in real software. Stacks are everywhere in real software. First, the function call stack. Every time your program calls a function, the CPU pushes a new frame onto the call stack to track local variables and where to return. When the function finishes, that frame is popped. Second, undo and redo in editors. Every action you take is pushed onto an undo stack. Pressing undo pops the latest action and reverses it. Third, bracket matching in compilers. When a parser sees an opening bracket, it pushes it. When it sees a closing bracket, it pops and checks for a match. If the stack is empty at the end, the brackets are balanced. One simple structure, 3 completely different problems solved. Next, let us bring everything together for a full recap. All right, let us bring it all together. A stack is a linear data structure governed by one rule: last in, first out. The last element pushed is always the first one popped. You interact with a stack through 5 operations: push, pop, top, empty, and size. In C++, you get all of this instantly with stdStack from the stack header. No extra setup needed. And as we saw, stacks power function calls, undo systems, and bracket validation in compilers. They are simple in concept, but foundational in practice. If you want to keep building on this, two great next topics are queues, which flip the rule to first in, first out, and recursion, where the call stack becomes something you can actually visualize. Thanks for watching, and we will see you in the next one.